Okay, let us now write the algorithms for the insertion and deletion operations for a double-ended queue. There will be 4 operations. As you know, insertion at the rear end, insertion at the front end, and deletion from rear as well as deletion from front. We need to initialize the front at 0, as I have discussed earlier in the previous lecture, and rear at -1. So now let me write the insertion at rear first. So procedure insertion at rear, and if the rear is at size -1, we consider the size as the size of the array. So if the rear is at size -1, then it's overflow, and just exit this operation. Otherwise, we have provision for addition there at the rear end, so we'll be incrementing the rear by 1, and then we'll push the element where the rear is right now. So if item is the array, then we'll place the value at the rear index. So the value that must be received by this function, and that is v. So that is the end of insertion at rear. Now let me write the procedure for deletion from rear. It's just the stack pop operation. It's just the stack pop operation, but we need to take care of the underflow condition. In this case, the underflow is going to happen if the front is greater than rear. In that case only, your array is empty, so you just need to print queue underflow and just exit from this. Otherwise, you need to pick up the value from the rear end and you need to decrement the rear by 1. So I'm getting the value from the rear index, and then I'll decrement the rear by 1. So that's the procedure for deletion from rear end. So let me now write the procedure for insertion at front, and this is going to receive a value v that is going to be inserted into the queue if the queue is not overflow. So in order to check the overflow at the front end, if the front is at 0th index, you cannot go down, right? You do not have a provision for -1. So if the front is at 0, then you cannot insert at front. So just print a message there, unable to insert at front, and then just exit this procedure. Otherwise, you can just decrement the front by 1 and place the value where your front is. So just decrementing the value of front by 1 and then placing the value that we need to insert at front at the front index of the array. So that ends this insertion at front. Now deletion from front. If the front is greater than rear, the underflow condition will remain same for both of the deletion cases. If the array is empty, you cannot delete an element from the array. Then just print queue underflow and exit from this procedure. Otherwise, what you need to do is to get the value from the front and increase the front by 1. So it's just like the queue operation, what we did in queue. So v equals get the value from the front, so item front, and then we'll be incrementing the front by 1 and then return v. That ends this deletion from front. Now here at deletion from rear, we need to return the value. I forgot to write that. So these are the 4 functions that we need to implement a double-ended queue. So in the next tutorial, what I'm going to do, I'm going to dry run these algorithms over an array, and we will see how this algorithm works to realize a double-ended queue practically. Okay, thank you very much.